Hi everybody, this is Katie. Welcome to Chapter 4, Decisions, Decisions. What should we do? Well, I have about 20 minutes. You know how I am with timing our videos out right. But we're going to talk about Chapter 4, and I'm going to point out the important things. I won't spend a ton of time hammering on them because you're going to have other videos with the code with me that will explain concepts, and also the homework assignment, which I'll probably make a little video for that as well. So, Chapter 4, starting on page 123, this talks about decisions. Introduction to decision structures, dual alternative. These are if-elses. Comparing strings is a little bit differently. Is done a little bit different using functions that are built into the system. And nested decision structures, the case structures, logical operators, and Boolean variables. Boolean variables store true or false value, just so you know, and that section is done. So, a decision structure is something that our program codes, that we code in our program that allows us to make choices. So, if age is greater than 18 or equal to 18, then you can do something like go into a bar that, well, that doesn't make sense. Okay, so if your age was greater than or equal to 21, then you could get a beer. Else you can't get a beer. Or, if your height is greater than or equal to 6 foot, then you're in the tall category. You have decisions that your program makes. The if statement is the single alternative. The dual alternative is what we normally do, and that's called an if then else. So you have two things going on. If age is greater than or equal to 21, then you may purchase this item, alcoholic item. Else you may not. So it's two things that happen, a yes or a no. Case structure, also called nested decisions. These are when we have more than two choices. So an if is one option. An if-else is two, and a case is more than two. Let's go through, let's see. Here's an example on this slide. This is a dual alternative or an if-else. So if temperature is less than 40, nice weather we're having. If it's true, it's a little cold. So it has a true and a false value. That would be an if-else. Just as an example. The pseudocode and the flowcharts, there's lots of examples in here. So I'm not going to go through them here because I want to keep this a short video because the other ones are longer. This table is super important though, our relational operators. This is what we write our conditions with. So our conditions are those things that we ask questions about. So when I said if age is less than, or if age is greater than or equal to 21, that greater than or equal to sign is this sign here. Do I have a pen option? Oh, I have a laser pointer. What did I say? Greater than or equal to. So that would be this option here, greater than or equal to. So you use those symbols on your keyboard. And that would include like 21, 22, and all the numbers above that. So you have your standard operators, less than, greater than or equal to, less than or equal to, and then the big one is equal to. In most languages, when you ask if something is equal to something, you use a double equal sign, like right here. In Small Basic, it is just a single equal sign though, and I'll point that out in our Code With Me video. It's kind of funky, but it's one equal sign is an assignment statement. Anytime you're asking if something is equal to it, then it's 2, except in Small Basic. The not operator is the exclamation point, and this is not an equals to. That's an opposite. So it's, if a value is not equal to that. Sticky note. I like my sticky notes. So just hammering out a couple examples of conditions that you might write for programs. And again, it could be many different things. So let's see. Here's an example. On page, just hammer out some conditions. On page 169, here, I got the textbook right in front of me, right here. Software sales. Or, let's see, 0 books, they get 0 points. So or book club points. So serendipity booksellers. So looking at this example, we get points when we, reward cards at places, we get points for that. So that's kind of what this one. If a customer has 0 books, they get 0 points. If they have 1 book, they get 5. So if you were to kind of write, just thinking about these bullet points right here, right down here with this question, if you were writing that out, you'd write a condition. So if is the keyword, and then your condition would be like books purchased. If it's 0 books, so you could say less than or equal to 0. Although, let's see, there's my logic error. I just put greater than, didn't I? But I said less than or equal to 0, but I put the wrong symbol there. Woo, back it up. That's why I'm not videotaping my face, because you didn't have to see me do a back it up dance. Anyway, you can't buy a negative book, so you could just say if book purchase was equal to 0, you could do it like that. Or you could say less than or equal to 0. If for some reason you're returning something, I don't know, then what you would do is say, okay, our points are equal to 0. So this part is a condition. If books purchased less than or equal to 0, that's condition, and we use relational operators in there. That would be an example. So if they purchase 1 book, and if you were writing that out, books purchased, if that was equal to 1, then their points would be 5. And as we see with some of our programs, we have a range that we want to check. And so like number 7 here, right here, it says, if quantity of software is between 10 and 19, then they get a certain discount. So that if statement might look like this. If quantity is less than, well, let's say greater than or equal to 10, and quantity is less than or equal to 19, and we'd put parentheses around the whole thing in most languages to make it one condition. So we have one huge condition with kind of 2 subconditions inside, or we have 2 conditions that make up one. Then we would say our discount is 20%, or however your calculation is. So this is an example of a range. So greater than or equal to 10, that would be 10, 11, 12. But then I say and less than or equal to 19. So less than or equal to 19 would be 19, 18, 17. It would be any number between 10 and 19 would be a range. So different ways you can do it. Now this uses both relational operators and logical operators. Oh, let's talk about that next. Talk try to keep some structure here. So relational operators, remember that. Our conditional operators, those are, let's see, those are I'll jump up ahead to that, logical operators right here. The and, the or, and the not. These go between conditions. So when you have multiple conditions, you use logical operators. The and, the or, and the not. And I try not to use not because it has me thinking backwards. I think backwards anyway, so I don't need to do that purposefully. But the and means both conditions must be true in order for something to happen. The or means one or the other must be true in order for something to happen. Now, I'm not sure with small basic if we can do logical operators, but I'll check. I know in the code with me, I don't require you to do that. In the assignment, if we can use logical operators, I will show you how to do that. So, in every programming language, the logical operators come in very handy because it's a way for us to combine conditions without having to nest our decisions, and it's super, super easy. So the and, both must be true. The or, one or the other must be true in order for something to happen. So those are logical operators. And when you look here, relational operators are within a condition. So see that relational operator? That's within a condition. Here's one within a condition. And then I have relational operators within this condition, But between those conditions, I have my logical operator, my and. Now look at this. If I took this line and I wrote the or symbol, which is pipes, or we'll just use or in pseudocode, what would happen here? So think about it. If your quantity was greater than or equal to 10, 11, 12, all the way up, or less than or equal to 19, that would cross the whole spectrum of numbers. So this would be a logic error because it includes all the numbers. Any number that's greater than or equal to 10 or any number that's less than or equal to 19, those, when I say or, it's either one and they cross paths. So that's wrong because it's a huge amount. It's all the numbers, and we just want this range. So this is the range, where you're checking to see if a number is between something. Okay? Not outside that barrier. So if you look at like a number scale, that's what I'm trying to see if I can. Well, I don't have like a, I want to write a number line with the things on it, but that's, I think you get what I'm talking about for the ranges. Okay, so we have conditional logical operators. Let's see, range checking. This is something that you do often for error code, and we're going to start getting into error code soon where we think, if it's wrong, we want to fix it. And that we'll start doing with our next chapter because we can't fix a problem without putting a loop in our code, and our loop goes back up. So chapter 5 is loops, but decisions are part of error code. And it uses our range checking or logical operators and relational operators for that. Now I'm jumping all over the place here, just trying to pull out some important things of the PowerPoint. We'll say nothing important there. Let's just go through the chapter real quick, and then I'll end. Just point out the important things that are going to be helpful for you for the assignments, and then also things that you want to read a little closer about, closer topics on. So page 1, decisions. It just tells you what a decision is. This is a simple flowchart. This is the singular decision. So if cold outside is true, wear a coat. There's no else. There's no false. Single alternative. The next page, combining structures. This is what this is talking about is in programming there's the three main structures. There's sequence, there's loops, and decisions. So we still use sequence in our program. We still do A, B, C, D, E, and then end. But we're going to go A, B, C, D, and then D is going to go off into its own structure and then come back. So we combine our structures to have sequence, and then in part of that sequence we go and do a decision, and then we still have sequence. And as you'll see with chapter 5 is we'll add a loop. So we have sequence and decisions, and then we go back up, or we go back around something. It's really quite fun. I like loops. I like loops. This is a little slow on the go here. There's the writing pseudocode or writing decisions in pseudocode, and this is pretty darn close to how you write it in Small Basic. Do the code with me because I'll show you how to code it in Small Basic, but they have the if, they have the then, they have an else if, which is one word we found out, and then they have an end if statement. Boolean expressions, these are variables that store a true or false value, and we'll do this later on in our class where we do conditions as part of our loops next chapter. But know what Boolean operators are, so they store the actual word true or the actual word false. It's a lot of times in programming we make those decisions, so it's quite useful. This is the table that you want to know. Relational operators, they're all pretty familiar from like 2nd or 3rd grade math, except that it's super easy to make those logic errors because you just hit the wrong one, or you say greater than and you put less than. Now, it's super easy for me. I seem to do that way more than I should for an educated person, but sometimes my mind goes faster than or slower than what my fingers can catch up with. Those are most of your errors with logic are here. You just put the wrong operator, you don't think it through. And one thing that I always do is I read my conditions out loud. It just helps me. This is the Boolean, or just an example of using your relational operators. The ones here, equal to, double equal sign, and then not equal to is not equal, and I tend to avoid that because it's kind of backwards thinking, so try to avoid that operator, and that's one of the things they suggest too as a standard programming practice. Read through this section. I don't think you want to listen to me go on and read it everything to you, but it does tell you what is an if, then else, and it gives you some more examples. So read through that. This is a program, this one right here, in the spotlight, this is a program that I wrote actually for this textbook when I did the user manual for it. And I assigned it for one of our, I think it was our midterm program, and then we had loops in it and some more things. We had a lot more things going on with it. But you take in test scores and then you average them out. So this gives you a good example of how you can determine, what grade you're going to get, like A, B, C, or D, based on test scores. So read through that in the Spotlight program and look at your decision. That would be a good assignment too, actually. I haven't written an assignment yet. Let me think about that. Dual alternative, these are the if-then statements. So if this is true, then, do this, else do this. So it's if, and then you can have any number of any number of statements in there. Else do this. It's one or the other. That's what an if-else is. And there's a good program to code too. It might be kind of nice just to code a program that the pseudocode's already written for us, but let me think about the assignment still. Go through that one. That you can even try to code that one, unless I make it the assignment. But the pseudocode flowchart, where it shows you, the directions your program could go. Actually, there's only one decision in there. It's not that great of a program, I guess. Comparing strings. If we do this in small basic, we'll have to figure it out if it's just the quotes equals quotes, string literal equals string literal. Things you have to be aware of is that uppercase and lowercase do make a difference with your string literals. So if you're comparing a capital no to a lowercase no, that would be false. They're not the same. And then some languages have special functions that you have to use to check to see if something is equal to something as far as strings go. Nothing that we really need to, that's what I just explained to you. But nothing that's going to pop out for our homework. It's important for when you get into your advanced classes, though, or go on with programming. On 41. Oh, that's still going on about strings and how each letter represents a block of memory and how you walk through string value. Okay. Nested decisions. I'm not even going to look at my time because I'm sure I'm over 20 minutes, but I'll keep going fast. Nested decisions is when you have more than two decisions. So, the if, then, else, two options. Nested decisions are something like if, then, else, if, then, else, if, then, and so on. So, a lot of times, you have more than two choices. If you took a test score and I was giving you an A or a B or C or D, I give you a A, B, C, or D. That's 4 options. Or E is 5. You don't just say A or B. If you're doing pass-fail, that could be A or B. That would be just a normal if-else statement. But in most cases, we have more than 2, so you write nested decisions. The flowchart and the pseudocode get quite long for those. Look through this part, and in your code with me, you'll do a nested if-then-else decision where you have multiple options that happen. My word of advice is when you open an if, end it right away so you don't get lost in what chunk belongs in what chunk. And in the Code With Me video, I lost my train of thought for a minute. In the Code With Me video, I do recommend and talk about indentation, so I won't talk about that here. Nested or multiple nested decisions, a lot of programs have more than 2 choices. The thing that we have to remember as programmers, this is where it gets useful to lay out your design of your code. Think about it, write out the flow to say, do I start at the top or the bottom? And the biggest logical error is you have a range that goes out of place, or you don't think through all of your decisions properly, or you just simply code it wrong, and even though it's the right text, it's just the right syntax, it's wrong logically. Here's a really good program that in the Spotlight, maybe this is the one I'll do. This is the A, B, C, D, or F program. And actually, that would be a good program. So we have the pseudocode where, you take a class, you get 10 points, and based on that, you're given a grade, or the following 10-point grade, 100-point. That should be 100. So you ask the test score, and then from there, you figure out what the grade is. There's different ways you can code these. You could code, that's why I said thinking about your design ahead of time makes more sense. Here they started with less than 60. So if your score is less than 60, you get an F. If you started at the top, like A, you would have to use logical operators. So if you wanted to start at the top, you have to say if score was less than or equal to 100, and score was greater than or equal to 90, then you get an A. Else, if score was less than or equal to 89, and I feel like I'm getting sick. I hope not. I'm talking too much, though. Less than or equal to 80. So then you get a B. Right? So if it's between 100 and 190, you have an A. Between 80 and 89, you have a B. So you could code it that way, but look how they did it here. They started on the opposite end. So what you then come up with is less code. Oh, that's a good idea. If your score is less than 60, you fail. Else, if score is less than 70, then you get a D. And then so on. Else, if score is less than 80, you get a C. Now, obviously, the benefit of doing this way is less code. And this way is using ranges. It's okay, but it has more chances for logical errors because we have more things going on. But because we're starting at the bottom in this case, because we thought about the program out, you can see that if this is true, the program ends. Well, if it's not less than 60, it's got to be greater than 60, right? So it goes here. So if it's less than 70, that doesn't mean that it's going to, that means this is basically the same as saying it's between, not basically, it is, it's between 60, because we didn't say less than or equal to 60, so it's between 60 and 69. Then you get a D. So we're doing kind of a de facto or default range when we structure it this way. Super, super important when you're coding, you're designing. Think about it, how you want to structure. Both ways are right. One way is just less work. That's a really good program. Maybe I feel like I'm overworking you guys. I do. I really do. Maybe I still haven't graded some things, and you're probably like, what is she doing? All right, we got a lot to learn, though, this semester. That page isn't coming up, so it must not be important. Oh, the if, then, else. Oh, it just, on page 148 is where I'm trying to be. 148 shows you how you can just continue on with that process. So you don't need to just have, it's not coming up. You don't have to just have, 4 decisions. You could have 20 decisions if you wanted. Now the alternative, or the problem that occurs sometimes is that when you have multiple decisions, you get lost in your code. So the alternative is something called a switch or a case structure. That's on page 150. Now, let's see. Whoops. There's all my things. Can you use case logic in small basic? Let's see what Google tells us. Let's see what you say, Magic Ball. A case structure is the alternative. I'll come back there in a second while it's going on. Let's see if my page came up. You know what? All the neighborhood kids are home from school and they're eating up my bandwidth. Darn you kids. Do I sound like an old person? Darn you kids. You rascal kids. I don't know what I'm talking about either. Oh, there's 150. Alright, finally. 150. This is your case structure. And I like cases because it's an easier way sometimes to structure your program. So you don't have to do ranges. You just say, you know, if grade is, or if month is equal to 1, then it's January. Else if month is equal to 2, then it's February. But instead of all of those nested if-elses, you present a menu and you ask a question at the beginning. Like, what is your month? If it's 1, do this. If it's 2, do this. And it's a lot neater in your syntax of the code and less, you know, if then else's that are all over the place. So this is an example of how you could code a switch structure. And I use them anytime I can replace a nested if. I will use a case structure. That's pretty common. Now, the magic question is, can we use them in small basic? And I don't want to get into go-tos. Go-tos are bad, bad, bad. Start talking about that right now. Go-tos are loops, are a way to bring your code up into a loop, but it's not the best way to code in languages because it's not supported on all platforms. So there's a basic if. See, they're using go to, don't do. Let's remember that. Go to, don't do. Do loops. We'll do loops next time. Subroutine, no, we know that. I don't think we can do a case structure in small basic, which is very unfortunate because they're awesome. Condition and loops, maybe? Branching and subroutines. I'll look around a little bit more, and if we can, in small basic, I'll add that to the assignment because it's a lot easier than your nested if-else. They do, this is good to know, so we're in small basic. Here's our normal operators. Our relational operators, look at this one here. Equal, 1 equal sign, that's what I was telling you about. The logical operators, this is good to know, so we can use 2 logical operators in small basic, the and the or. You're going to do that for your assignment probably because, you know, or if you were coding that grade 1 and you did it backwards, you'd have to use it. So you would just use the word and or. And true and false, so you can have true and false values for Booleans. So that's kind of cool. You learn a little bit about small basic. Power of Google. Where were we? Oh, we were on the... Okay. I think that's it for now. I think that you get an idea of the chapter. You know, you have to read this material too. So read it. That will help understand what we're talking about. And do the code with me next, and then do the assignment. Remember, all of these things that we're learning, we're building up. And pretty soon we'll be doing an exam where you've learned your sequence, and then you're adding on your decisions, and you're adding on your loops, and you're adding on your range checking. So you're developing these good programming skills, building on them chapter by chapter. So thank you. Let's see how long we went. Oh, not too bad. Have a great day. Do the code with me next. I already recorded that one. It's a fun one about area of rectangles. Have a good day.